Kia ora Year 12 and Year 11. This is an excellence question from the 2008 calculus exam, and it's about a piece of wire that is cut into two pieces. So we're told that a piece of wire is 40 centimetres long and it's cut into two, and then one piece makes a square and the other piece makes an equilateral triangle. We need to find the length of the wire used for the square if the sum of the areas of the two shapes is a minimum. So I'm going to make that side length y and that one x. So pause the video now and see how far you can get without any hints from me. It's the usual idea. We figure out what we're trying to minimise, which we'll call A, and that's where the hard thinking is in this question. The rest of it is really just algebra, but a little bit more algebra than you're used to in calculus questions. So we're going to minimise A, and we know that the piece of wire has to be 40 centimetres long. Okay, so in this case, what I'm going to do first is I'm going to write down that constraint. So we know that 40 must equal the length of the wire used in the square. So that's going to be this side, this side, this side, and this side. So that'll be 4y. And in the triangle, the lengths will add up to 3x. Okay, and we're going to rearrange this eventually. But first we need to figure out what's the area of the square and the triangle. So we're going to do that on a new slide. Well, the area of the square, that's a square, in case you were confused, is y squared. But what about the triangle? Well, the area of the triangle is half the base times the height. Now we know the base is x because it's equilateral, but what is the height? So to figure out the height, we're going to need to use Pythagoras. So we have x squared is equal to what? Well, the whole base is x. But if we're going to use Pythagoras, we need a right angled triangle. So that means that this bit here is x on 2. So x squared, the hypotenuse squared, is equal to x on 2 squared plus h squared, which gives me h squared is equal to 3/4 x squared. Right, so I'm doing that by just making that into x squared on 4 and subtracting from both sides. So that gives us x is equal to √3 divided by 2 times x. So I'm ignoring the negative solution there because I'm dealing with a triangle and lengths have to be positive. So this is h. So that means now I can get an expression for the area of the triangle, which is going to be half times the base, which is x, times the height. So √3 on 2x. So that equals √3 divided by 4 x squared. So I need to now combine that with the area of my square. Okay, so that gives me a total area formula, and that's coming up next. Right, so A is equal to y squared plus √3 on 4 x squared. But we already had our expression for the length of wire, which was 4y plus 3x equals 40. So I can rearrange that and get y is equal to 40 minus 3x divided by 4, which equals 10 minus 3/4 of x. So as usual, I take that and I substitute it into my area formula. So I get A is equal to this right. So expanding this, I'm going to get 100 minus 2 lots of 30 on 4x, which obviously we're going to fix up, plus 9/16 x squared plus the triangle area, which is that. Right, so now I've got an expression for the area completely in terms of x, which is the side length for the triangle. And I can differentiate because I've got down to one variable. So that's what we're going to do now. Okay, so for a minimum, we require that the first derivative, dA by dx, equals 0. So what is that first derivative? dA by dx is equal to -15 plus, now let's do each of these x squared bits in their turn. Right, so it's going to be 9/8 of x plus root 3 on 2x. Now I've just realised that I'm doing that with a piece of paper in front of me, but let's just put back in what the expression was. So we had a was equal to 100 minus 15x plus 9/16 x squared plus root 3 on 4x squared. Okay, so what's going on with these bits is that I'm taking that 2 and I'm multiplying that through. So that's where the 9/8 comes from. I hope that made more sense than it just did when it came out of my mouth. But there you go. Okay, so now the last thing we've got to do is we need to solve for x. So we get x times 9/8 plus root 3 on 2 is equal to 15. So x is equal to 15 divided by that. Now we could be good and go through and turn that into a nice fraction, and actually I'm going to do that, but I know that many of you are going to groan. But here we've got all of this we can write as 9 plus 4 root 3 divided by 8. I think that's not going to show up because of the screen. Okay, but it simplifies to 120 over 9 plus 4 root 3. Okay, I feel much better now. I know that some of you just did that on your graphics calculator. Anyway, that gives me a value for x of 22.6 centimetres. But that's not what we were asked for. That is the side length of the triangle. So the last little step is to figure out what's the side length of the triangle. And I'm going to avoid a new slide by just popping it in over here. Right, so y is equal to 40 minus 22.6, which equals 17.4 centimetres. So if you were doing that in the exam, then you'd write a nice note saying the length of the square must be 17.4 centimetres to minimise the area. Okay, so that's all for today. Hope that helped, and really make sure you've gone through the algebra in that question, and also how we used Pythagoras, because that's a really useful trick to help us with harder calculus problems. Thanks for watching.